Good day, everyone. We are in General Mathematics, and I am Mr. Jemerjo Isalandanan, your subject teacher and the current Senior High School Coordinator of Cuenca Institute. Today, we are going to utilize another module in General Mathematics entitled Basic Business Mathematics. This module introduces mathematical concepts in business. These are essential to real-life activities such as investing money in banks. This module also includes applications of simple and compound interest in both personal and business management and presents varied situations applying the idea of borrowing and investing money. Through these, you can virtually relate mathematical concepts in personal and business contexts. Now we are going to continue our lesson number 7, which is all about interest. What will you learn in this lesson? First, you're going to explain how money grows in a compound interest environment, as well as you're going to solve problems involving compound interest. Interest is the amount paid by a borrower to a lender for a credit. Also, an interest is the amount gained on an investment. The value of the interest depends largely on the interest rate, the borrowed or invested amount, referred to as the principal amount, and the length of time the principal is invested or borrowed. Examples of interest include interest paid for bank loans, bond yields, and returns on savings. Interest is generally computed as a percent of the principal. The percent of the principal paid for the use of money on a certain length of time in an investment or loan is called the interest rate. The time is generally expressed in terms of years. There are two types of interest, the simple interest and the compound interest. The simple interest is an interest which is computed entirely at once from the moment money is borrowed or invested until it will be paid. Whereas compound interest, it is an interest added to the principal of an investment or a loan, so that the added interest also earns interest from then on. This addition of interest to the principal is called compounding. In a simple interest, the principal is constant all throughout the term, while in a compound interest, the principal increases repeatedly by adding the interest at a given interval throughout the term of investment or loan. Let us have an example. Let us compute and compare the future values in simple and compound interest on a 50,000 loan at 3.5% interest rate annually after 4 years. So we are going to compute and compare the future values of this scenario in both environments, simple interest environment and the compound interest environment. Again, the given problem, compute and compare the future values in simple and compound interest on a 50,000 loan at 3.5% interest rate annually after 4 years. Let us state the given facts. At a simple interest environment, the principal amount is 50,000. The interest rate is 3.5% expressed in decimal will be 0.035. And our time is 4 years. In order for us to compute for the future value, there is a need for us to compute first for the interest. Okay? So using the formula I is equal to P times R times T, we will be able to compute for its interest, the simple interest. Okay? So let us substitute the given information to the formula. I is equal to 50,000 times 0.035 times 4, giving us an interest of 7,000 pesos. If the interest is 7,000 pesos, the principal amount is 50,000 pesos, we will be able to compute for the future value using this formula. The future value equals the sum of the principal amount and the interest. So F is equal to P plus I. We have F is equal to 50,000 as the principal amount plus 7,000 as the interest, giving us a future value of 57,000 pesos. So in a simple interest environment, a 50,000 loan at 3.5% rate annually after 4 years will be 57,000. Now, using the same information that the principal amount is 50,000, the interest rate is 3.5%, and the period would be 4 years, let us compute for the compound interest environment. Okay, so this is the given problem. Now, since we are in a compound interest environment, there is a need for us to compute the interest of the given information year by year or every compounding period. So in this case, we have 4 years. Therefore, we are going to compute it 4 times. So let us have the first year of compounding. Let us compute for the first year of compounding. At compound interest environment, the principal amount is 50,000. The rate is 3.5% or 0.035, and the time, look at the time. The time is not 4. The time is 1 year because we are going to compute this 4 times, year by year by year by year. So in the first year of compounding, the interest would be something like this. I is equal to P times R times T. I is equal to 50,000 times 0.035 times 1. Remember that the time is 1 year. The interest here is 1,750. Let us compute for the future value after 1 year. After 1 year, the future value would be F is equal to P plus I. F is equal to 50,000 plus 1,750. The future value after 1 year or during the first year of compounding is 51,750. Okay? So 51,750 is the future value of the loan after 1 year. Okay, so that is after 1 year in a compound interest environment. This 51,750 will be the new principal amount for the second year. So let us proceed with the second year of compounding. In the second year of compounding, the principal amount will not be 50,000. Instead, this will be 51,750. So that is the principal amount plus the interest. So here, there will be an interest on an interest. Okay? So the new principal amount is 51,750. Our rate is 3.5% or 0.035. And the time, don't forget that is still 1 year. But remember that we are in the second year of compounding. So let us compute for the interest. Given P is equal to 51,750, the R is 0.035, and the time is 1 year. The formula I is equal to PRT. I is equal to 51,750 times 0.035 times 1, giving us an interest of 1,811 and 25 hundredths. Okay, so this is the interest after the second year of compounding. Okay, so this will be added to our previous principal amount. Okay? So the future value would be F is equal to P plus I. Our P here would be 51,750. And our interest would be 1,811.25. So our future value would be 51,750 plus 1,811.25, giving us the future value for the second year of compounding as 53,561.25. Okay, so we will proceed on our third year of compounding. But take note of this. Take note of this value because this will be the new principal amount on the next compounding period. Okay? We are now in the third year of compounding. So our principal amount would be 53,561.25. Our rate is still 0.035 and our year is or our time is 1 year. Remember that the one that is changing is the value of the principal amount because we are adding the interest in each compounding period. Okay, so let us compute for the interest here. I is equal to PRT, I is equal to 53,561.25 times 0.035 times 1, giving us an interest of 1,874.64. Now, we are going to compute for the future value after the third year or on the third year of compounding. So, F is equal to P plus I. Here, in order for us to compute the future value at the third year of compounding, our principal amount will be this one, 53,561.25, and our interest here is this, 1,874.64. Okay, so let us substitute the two values here. F is equal to 53,561.25 plus 1,874.64, giving us a sum of 55,435.89. Okay, that is the future value after the third year of compounding. Please take note of this value because this will be the new principal amount on our next compounding period. Okay? So please be reminded that we are having four counts of compounding because here the word annually and after 4 years, so meaning to say we have 4 years to compute, 4 periods to compute. Okay, so we are done in our three compounding periods. Let us proceed with our last compounding period, the fourth year of compounding. Please be reminded that the principal amount will change. So P now, or the principal amount now would be 55,435.89. Our rate is still the same, 0.035, and our time is still 1 year because we are in a compound interest environment. Let us compute for the interest. I is equal to PIRT. I is equal to 55,435.89 times 0.035 times 1. I is equal to 1,940.26. Now, let us compute for the future value of the loan. The future value of the loan, the 50,000 loan at 3.5% interest rate annually after 4 years because this is already our fourth year. This is the last year of compounding. So the future value would be P plus I, 55,435.89 plus 1,940.26, giving us 57,000 rather, 57,376.15. This is the future value. This is the future value in a compound interest environment. Okay? So what if we are asked to compute for the interest? So let us have this. At the end of the term, also referred to as the due date or the maturity date, the principal will be paid together with the interest. The sum of the principal and the compound interest is called the future value, denoted by F. Again, the maturity value is the same as the future value, and that is also the same as the accumulated value. So any of the three terms can be used in determining or in pointing out the sum of the principal and the compound and the principal and the interest. So in our case, we are using maturity value for the simple interest, and we are using future value for the compound interest. Okay, so these terms are these terms mean the same. Okay, so the future value is the principal plus the interest. If we are looking for the interest rate given the principal and the future value, we're just going to subtract the principal from the future value. So future value is quite higher compared to principal and the interest. That's why that would be our minuend. Okay, F minus P. If we are looking for the principal amount given the future value and the interest, let us just subtract I from F. Okay, so in a given problem, compute the compound interest of a 50,000 loan at 3.5% interest rate after 4 years. In a given problem earlier, if we are just going to compute for the interest of the given problem, so we're just going to subtract the principal amount, the 50,000 from the future value, 57,000. Okay, so I is equal to 57,376.15 minus 50,000 give us 7,376.15. This is the interest in a compound interest environment. Okay, so let us compare. We are already done computing for the interest or the future values in a simple and compound interest. Now let us compare. So the table below shows the summary of the results of the previous computations, so we can make a further comparison between simple and compound interest. Here, in a simple interest, the principal amount is unchanged. From first year to fourth year, that is 50,000. No change. The interest, since we're going to compute it only once, gives us 7,000. The future value at the end of the period in a simple interest environment would be 50,000 plus 7,000 gives us 57,000. Whereas in a compound interest, we are going to compute it every period. Okay, so here, since the given is 4 years compounded annually, so we have 4 compounding period. In a first compounding period, the principal amount is 50,000. The computed interest is 1,750. We're just going to add the two in order for us to get the future value. Now, this future value of the first compounding period will be the principal amount of the next compounding period. So 51,750, which will earn an interest of 1,811.25. We're going to add the 2 in order for us to get the new future value. And this new future value will be the next principal amount of the third compounding period. The computed interest here is 1,874.64. We're just going to add the 2 in order for us to get the new future value. This future value will be the principal amount for the last compounding period. The computed interest is this, and the future value is 57,376.15. Now, let us take a look at the values, the future values under simple and compound interest. In a simple interest, our future value is just 57,000. Whereas in a compound interest, the value or the future value is 57,376.15, which is quite higher compared to that of the simple interest. So based from the table, the amount grows faster in a compound interest than in a simple interest. In compound interest, the interest from the first period is added to the principal to get the final amount. Then, the final amount will be the new principal for the start of the next period, and so on, thus making the interest higher than the previous period. Okay? So, if we are going to do this in every problem, that is very tiresome. That is very tedious. Napakatagal niyan. Napakahaba. Kasi kung marami tayong kukomputing ganyan, nakakapagod. That is why there is a need for us to have a simpler method. Paano ang gagawin natin para makompute agad natin yung future value? Para makompute agad natin yung interest nang hindi na natin dadaanan yung kada taon na iyan. Okay? So, there is a need for us to discuss the future value in a compound interest environment. Okay? So, here we are going to compute for the future value in a compound interest environment using a formula. The future value in a compound interest. The general formula in finding the future value in a compound interest is given by F is equal to P times the quantity 1 plus R divided by N, quantity raised to the NT. So in this particular formula, please be reminded that the rate will be divided by the value of N, the time will be multiplied to the value of N, the value of this will be added to 1. Then we are going to utilize the exponentiation feature of a scientific calculator because here there will be an exponent before we multiply it by P for us to get the value of F. So please be reminded that in this particular formula, F stands for the future value in a compound interest environment. P is the principal amount or the actual money borrowed or invested. R is the interest rate per conversion. This is also referred as the periodic interest rate. Unlike in a simple interest environment, we are referring R as the annual interest rate. Here, in a compound interest, we are going to use or we're going to refer R as the periodic interest rate. N is the number of conversion period or the total number of payments in a year. Ilang beses tayo i-compound sa loob ng isang taon? That is the value of N, kung ilang beses kino-compound sa isang taon. And the time or the T is the time in years. Okay, so this is the formula in order for us to get the future value in a compound interest. Okay, future value in a compound interest. F is equal to P times the quantity 1 plus R divided by N, quantity raised to the N times T. So for us to know the value of N or kung ilang beses ba natin kino-compound ang ating pong problem sa isang taon, we are going to look for these terms and words. If the presented word is annually or yearly or once a year, the value of N is 1, meaning to say, isang beses lamang kino-compound sa isang taon. Okay? If the words presented there in a problem are semi-annually or twice a year or every 6 months, meaning to say, the value of N would be 2. Meaning to say, twice a year, 2 times a year, dalawang beses i-compound sa loob ng isang taon. Semi-annually. So, mga yan, ang value niyan ay N is equal to 2. If the words presented in a given problem are quarterly, 4 times a year, or every 3 months, the value of n is 4. If the presented words there are bi-monthly, every 2 months, so the value of our n is 6 because there are 6 2 months in a year. If the word is monthly, so we all know that there are 12 months in a year, so the value of n is 12. If that is daily, we can use 365. Not 360, not 366, but 365. Okay? So how are we going to determine whether the given problem falls under the simple interest environment and under the compound interest environment? So these are the clues. If these words, the annually, semi-annually, quarterly, yearly, bi-monthly, monthly, daily, if these words are presented in a problem, there is a higher chance that we are dealing with a compound interest environment, especially if the word compound or compounding or conversion. So these are the words that signify compound interest. Okay, so let us have problem solving. These are the problem solving in a compound interest environment. If 500,000 is deposited in a bank paying 8% interest compounded quarterly, how much will be in the account at the end of 10 years? So in this particular problem, let us uh, determine first kung ito ba ay simple interest or compound interest. Tingnan ng words ay may compounded quarterly. So alam natin na ito ay papatak sa compound interest. Okay? So, alamin natin ang ating mga given dito. So, if 500,000 is deposited in a bank paying 8% interest compounded quarterly, ibig sabihin ng quarterly ay 4 na beses sa isang taon, how much will be in the account at the end of 10 years? So, the given information, P is equal to 500,000 because that is the principal amount deposited in the bank. Our rate is 8% or 0.08. Our time is 10 years. The value of n is 4 because it is stated here that the deposited amount in a bank will be compounded quarterly. So we are looking for how much will be in the account at the end of 10 years. We are looking for the future value. This will be the amount in the account at the end of 10 years. Okay? So let us compute for the compound interest before we can compute for the let us compute for the future value of this problem. Okay, using the formula, F is equal to P times 1 plus R over N times NT. Okay, let us substitute 500,000 times 1 plus 0.08 divided by 4 times 4 times 10. So let us compute this simultaneously. Ito muna, bago ay ito. So 0.08 divided by 4 gives us 0.02. 4 times 10 ay 40. Yan. Pag na-compute mo na ito, pagpaplasin mo naman, 1 plus 0.02 is 1.02. Raised to the 40th power, that is 2.2080. Kapag nasa problem tayo mga tutoy, i-round off nyo na sa 4 decimal places while we are in the process. Okay? So 2.2080 times 500,000 gives us 1,104,000. Okay? So, tapos dito sa final answer, ay di 2 decimal na lamang. Okay? So, the future value is 1,104,000 after 10 years. There will be 1,104,000 after 10 years. That would be the amount in a bank. So, that is easy. That is how easy solving for the compound interest is. Another problem, if 25,000 is invested at 8.2% compounded monthly, how much is the future value and the compound interest after 2 years? So here we are looking for two things. How much is the future value and how much is the compound interest after 2 years? So before we can compute for that, for those things, let us find first or let us determine the given information. Okay, So the principal amount is 25,000. The rate is 8.2% or 0.082, 0.082. Our investment has been compounded monthly, so the value of n is 12 because that is monthly. How much is the future value in the compound interest after 2 years? Our T is 2 years. Okay? So we are looking for the future value in the compound interest. Let us compute here. Let us compute first for the future value. F is equal to P times 1 plus R over N raised to the NT. Let us substitute 25,000 times 1 plus 0.082 divided by 12 raised to the 12 times 2. So 0.082 divided by 12 is 0.0068. 12 times 2 is equal to 24. So we're going to add this first. 1 plus 0.0068, that is 1.0068 raised to the 24th power gives us 1.1766. 4 decimal places na lamang tayo. Rounded to 4 decimal places. 1.1766 times 25,000 gives us 29,415 pesos. This is the future value. We attain this given or we attain this unknown. Now we're going to compute for the compound interest. In order for us to compute for the compound interest, given the future value and the principal amount, just subtract P from F. I is equal to F minus P. I is equal to 29,415 minus 25,000 gives us 4,415. So meaning to say, if 25,000 is invested at 8.2% compounded monthly, after 2 years, the interest would be 4,415, giving you a future value of 29,415 pesos. Okay? Another problem. Another problem. At what interest rate? So we are looking for the interest rate. At what interest rate, compounded annually, must 10,000 be invested in order to earn an interest worth 2,000 in 5 years? Okay? So there is a desire to earn a 2,000 interest. Your principal amount is 10,000 and the time that you are giving for your money to grow 2,000 is 5 years. Okay? So the given information, P is equal to 10,000. N is 1 because it is compounded annually and is equal to 1. The interest is 2,000 and the time is 5 years. We are looking for the interest rate. Now, this might be confusing, but please focus on solving this interest rate. For the future value is the sum of the principal and the interest. Okay? So we all know that the future value is the sum of the principal and the interest. F is equal to P plus I. F is equal to 10,000 plus 2,000. F is 12,000. Why is there a need for us to compute for the future value? It is needed because in our formula, we must provide the value of F. Okay, so here, F is equal to P times 1 plus R over N raised to the NT. The value of F is now 12,000. That is the sum of 10 and 2,000. 10,000 and 2,000 gives us 12,000. The value of our P is 10,000. R is unknown divided by 1. So R divided by 1 is R. 1 times 5 is 5. Okay? So here, 12,000 is equal to 10,000 times 1 plus R raised to the fifth power. We're going to divide both sides by 10,000 in order for us to eliminate this part. Okay? So, 12,000 divided by 10,000 gives us 1.2. Since this has been eliminated, what is left here on this part is 1 plus R raised to the fifth power, and this would be 1.2. Okay, so here we have 1.2 is equal to 1 plus R to the fifth power. Now, in order for us to isolate R, let us cancel 5 here. How are we going to cancel a power? We can cancel a power by extracting the roots of both sides. Okay? So if this is raised to the fifth power, extract the fifth root of both sides. The fifth root of 1.2 is equal to the fifth root of 1 plus r to the fifth power. If we do this, there is a time for us to cancel this part. Because if the index and the power or the exponent are equal, we can cancel them, leaving us only the radicand 1 plus r. Okay? So 1 plus r is equal to the fifth root of 1.2. Okay? So in order for us to get the value of r, just subtract 1 from to the both sides. R is equal to the fifth root of 1.2 minus 1. The fifth root of 1.2 minus 1 is approximately 0.0371 or 3.71%. Okay? So that is how easy solving compound interest is. Or that is how easy working on a compound interest environment. Okay? Is there any question? None. Very good. Now, let us have an activity. You're going to try this. Answer this problem. This problem is located on your module. Okay? So you can see this in your module sa page 6, mga tutoy, mga ining. May espasyo talaga doon, ha? Answer the problem on the space provided in your module. Take a picture of your answer. Pag nasagutan nyo, take a picture of your answer and upload your file in our Google Classroom on or before November 11, Thursday. Kailangan to gawin kasi kasama to sa exam natin sa ating semifinals. Hindi ko kayo ma-meet ng Monday, Tuesday, and Wednesday and Thursday because ako po ay nasa webinars na kinakailangan naman ng senior high school. And on Thursday, pupunta ako sa Cainta Rizal for the issuance of the special order ng grade 12. Kaya hindi ko kayo ma-meet. Kaya naman, ito ang ating gagawin, ha? Kung talaga napanood nyo, gagawin nyo ito. And ipapasa sa Google Classroom on or before November 11, Thursday. Make sure to write your name and section doon po sa, yung makikita ko naman. Ano? Okay, this is the given problem. Answer the given problem on the space provided in your module. 5 years ago, Arnelyn put her savings worth 10,000 in an account providing a compound interest rate of 3.5% annually. Find the value of her savings today and the amount of interest. Okay? That would be all. And announcement. Mga tutoy, mga ining, ano nga pala ang sasabihin ko? Mag-aral. Magiging coverage lang ng ating semifinals on November 15 and 16 would be interest, simple and compound interest. Okay? That would be all. Yung mga hindi pa nakakapagsagot sa ating Google Classroom ng quiz, dapat ay makapagsagot na kayo. Sa ating Google Classroom, doon nyo rin makikita ang ating yung sasagutan sa essay, no? Quotations rather. And this is that quotation. Do not save what is left after spending, but spend what is left after saving. Okay, that would be all for today. Goodbye. Thank you very much.